Welcome, everybody. It's a Thursday, and that means only one thing over here on MongoDB TV Cloud Connect, and that means we are broadcasting live again, and we've got a great episode, a great show lined up for you today. For new viewers, I'm Shane McAllister. It's a pleasure to meet you. I'm a lead on the developer advocacy team here in the developer relations group here at MongoDB. And for regular viewers, you're very welcome back. It's good to have you again. We are streaming on YouTube and on LinkedIn. So in today's show, we're going to learn all about how to generate, store, index vector embeddings with Google Cloud and MongoDB Atlas. But firstly, while we're waiting to get underway, do let us know where you are, where you're tuning in from, who you are. We'd love to hear from you. And once we get underway, if you have any questions, please put them into the comments, both on YouTube and on LinkedIn, and we'll look after those. We'll take some of them live on air to answer them as they suit. Others we'll address towards the end of our episode as well, too. As I said, we do this every Thursday for Cloud Connect show here on MongoDB TV. So go to our YouTube channel, MongoDB's YouTube channel, and go there and see the live tab for our forthcoming episodes and also for our previous episodes as well, too. It is being recorded, so will be available afterwards. So if you can't join us live, there's no problem whatsoever. Or if you need to duck out early and you don't get the rest of the show, that's fine too. Don't worry if you cannot stay for all of it. And if you're not watching live, although you won't be able to put any comments in or interact with us, do add your comments in underneath, and we will look at those and try to respond to you as well too. On YouTube, don't also forget to like and subscribe as well too, please, if you haven't already. That really helps us broaden the reach and scope of our channel. Anyway, as I said at the beginning, this Cloud Connect is all about AI. It's everywhere these days. It's a lot of buzz, and maybe it's not so clear how to practically use it. But before I get on any further, I'm going to bring somebody who does know how to practically use AI. Mira, welcome to the show.
Hi, Shane. Well, how to use it? It's a bit rich, but yeah, I'm trying to.
Well, I think in the world of AI, everybody's trying to figure out how to do things and build with it. I think the speed and the scale and, you know, how it's impacted, I think, every part of a developer's life is enormous. So I know you've been playing with it quite a while. I know at the MongoDB.local London we had on Tuesday just gone by, most of the conversations were about AI. It seemed to be generally everywhere. So I think, myself included, I think the audience are really looking forward to seeing what you have to show to us today. And, what are you going to take us through? What are they going to learn?
Yeah, indeed. Today we're going to focus a bit more on vector search. You and I, we were together at Google Cloud Next as well
Mm-hmm.
a couple weeks ago, and a lot of people were asking, so where does MongoDB fit in all this AI buzz? How do you integrate Google Cloud's AI platform with MongoDB? And I guess the most straightforward and honest answer is that we can store vectors in MongoDB, and we can properly index them and use them for vector search. Now, there is like a vast majority of use cases that can be solved using vectors and vector search and text embeddings. Today, we will focus more on the basics. How do we actually generate these embeddings using Google Cloud's models? How do we store them in our MongoDB database? And what do we do with them afterwards? And why do we actually need vector search as well? Probably
Excellent.
that's the biggest
Yeah,
question.
maybe that's the question to answer first. I think the key thing, I suppose, obviously, we launched and announced vector search back in June at .local New York, or the end of June, beginning of July. It seems like a while ago now. And the key thing there is that, you don't need to stand up anything extra. Your vectors are stored in MongoDB Atlas alongside your data, which I think for anybody with their data already in Atlas is a huge benefit, a huge bonus. The other thing is a huge benefit and bonus too, is that we can work with all of the Gen AI tools that are out there. So you're not constrained in that respect. In this instance, we're going to look at a lot of the Google Gen AI tools that we have available, but other cloud partners do exist, and we can work with all of them. Isn't that right?
Yeah, that's true. That's true. And let's be honest, like other vector databases exist as well. They have been around for a while, and vector search and using vectors in machine learning is not a new thing. It's not something that we discovered and started doing because of the recent buzz of generative AI. They have been around, and they have their adoption and their use cases. In fact, I've learned that MongoDB has had kind of a private preview of vector search long before this year. And probably the advancements in the space have facilitated this feature and prompted MongoDB to make it public and to make it available to the wider audience. But the truth is that vector search is not a new thing. It's not something that we just decided is cool. And MongoDB has other ways to find data and to use full text search and basically to build a basic search functionality with kind of the search functionality that you want in your e-commerce or in your application. You can use just $find with the regex, right? That has been available from the very beginning. We also have Atlas search, which is a keywords-based search on top of Lucene. And that is something that probably most businesses out there use, like a keyword-based search. So why do we need vector search, though? Does it solve any actual problems, or is it actually trendy and that's why people want to use it? That's probably the bigger question here. And we probably won't be able to fully answer that today, but at least we'll give you the tools to try it yourself, play with it, see if it works in your application, and see what you can do with it.
Excellent. And we'll be sharing some links along the way as well too. And for those that are joining just now, please do introduce yourself on the comments. Let us know where you're joining from. Again, like all of these streams, we have people from all over the place, and we realized, all the way through from Dubai, India, Brazil, Mexico, Pakistan. It's amazing to see the wealth and size and scale of the audience that we have tuning in. So you're very welcome. Please introduce yourself if you haven't already. And as we go through, and as Mira shares some of the examples and some of the use cases and runs through part of the demo, if you have any questions, do post them. If they're suitable for the time that we're in, where Mira is in the demo, or for, it adds more clarity to the point that we're at, we'll certainly bring them live onto the stream and we can answer them directly. And if we still have time towards the end of this stream, we'll certainly take some more questions. But I think, Mira, let's get started. And I'm going to throw your screen up here now. Pop it up there.
Yeah.
We're going to see ourselves, and away you go.
Amazing. Yes. So we see here a little demo that I built with vector search that demonstrates the semantic search capabilities of using vector search. Now, let's see what that means. As you can see, it's just like a regular book catalog. We have a bunch of items, and we have a search bar. Nothing unusual here. We could very easily implement this with keyword search. But the thing here is that we are able to search for items, in this case, books, based on the semantic meaning of the query that I type in here. Now, this is a very tiny data set. It has about 600 books, and I had to find some suitable queries to demonstrate that. But one good one that they came up with is searching for Harry Potter. Now, we don't have any of the Harry Potter books here in the data set, but if I search for Harry Potter over here, it takes maybe a couple of settings to load. We will see some results, even though we don't have the exact Harry Potter books. And the results are quite interesting. So we have The Magician's Nephew, which is kind of a fantasy book from the 1950s. We have So You Want to Be a Wizard. We have The Amber Spyglass, which is a fantasy book, I think. And we have other books that kind of contain the words magician, wizard, or have something to do with science fiction or fantasy, more specifically fantasy. How does that work? As I said, the biggest benefit to this example that demonstrates vector search is that we are able to search by the semantic meaning of the query. Now, this seems quite magical, but we're going to go through what happens behind the scenes to make it work. Let's try another query. I had some pretty interesting ones here in my notes. Right, so if we search for horror, it's like another similar example. We don't have the keyword horror anywhere here, but we still get some books that are, well, that are of this genre. We have a book by Lovecraft that is a horror book. We have House of Stairs. This looks pretty gloomy, so I assume it's also a horror book. And you can see that we kind of find relevant results. If you have ever searched in, let's say in Netflix for a movie that is not available, you get similar results. Now, this is kind of the same idea. You don't see the exact same word that we searched for, probably because it's not in the data set, but you see similar results that are semantically closer to what you searched for. Something other
I think
interesting.
everybody's had the issue with, search on websites not revealing what they really wanted to reveal, and either it's revealing something entirely different, or you did a typo and all of a sudden you're seeing a different set of results than you were expecting. So semantic search in itself is incredibly powerful, right?
Yeah, indeed. And things like typos can be easily resolved using keyword search. If you enable fuzzy search, you can say ignore 1 or 2 characters or 3 characters that don't quite match the word in the search results, but still return it. And this is cool. This horror example can also be solved with synonyms. If you're using traditional keyword search, you can say that terror is, or a psycho is just a synonym of horror, and that's why you will see these 2 results if you search for horror. But this is not the same as actual vector search that allows you to perform semantic search. Another cool example that I had here, and this is the last one, is ancient civilizations. Now, again, we don't have the words ancient. Oh, we do have it here in ancient Egypt, so we can kind of justify why this shows up. But we don't really have ancient in any of the others. We
Hmm.
have some other ancient Egypt books here, Neanderthal. I guess that's also quantifies or qualifies as ancient. And we don't have civilization anywhere. But we still got these results because they are semantically close to the query that we typed in. You might also notice here that I have this field called relevance score. So the results are scored by their relevancy using a similarity function. We'll go into that in a bit more detail later. But the quirky detail here is that they're scored from 0 to 1, and they're also usually looking like this. They have like a lot of digits after the decimal point, and yeah, you have some. Obviously, you see the highest first in the list, and as you go down, you see lower numbers.
It's nice to expose that in the demo. It's great to see, because usually, obviously, if this were a proper site, that would all be hidden behind the scenes. So it's great to have that there.
Yeah, and this is kind of the score that gets scored by Atlas search that we are using for the vector search.
Mm-hmm.
All right, so how does that work now? Again, vector search, really powerful. It is based on machine learning, and it uses something called vectors, as you might guess from the name. And vectors are just lists with numbers, usually from -1 to 1. They are fractional numbers, or what was it, a floating point number, the exact name of this. Usually with a lot more digits after the decimal point, and they are usually quite long lists. The model that we're using today, which is Google Cloud's text embedding-gecko model, generates a vector that has the size of 768. So we have 768 numbers in this vector.
You weren't going to add those to the slide.
I definitely wouldn't have added this. And I saw like a tiny question or a comment right when we started, if we can show how to embed images and audio and other formats or other media. We're not going to show that, but it is possible. Usually the vectors that are generated from that type of media that is a lot richer than just text are longer. So we have, I think the image model that is used for generating an image vector in Google Cloud is 1,500 points long. And you can store that in MongoDB Atlas, and you can index it as well. So that is definitely possible.
Okay. Well, we're on about the questions that popped up. There was another one, which was how vector search tool differs than Elasticsearch in terms of storing and searching an index. From my understanding, obviously, Elasticsearch is semantic search using natural language processing, and very similar, right?
I think Elasticsearch is also based on Scene, similarly to Atlas Search, and it's basically a keyword search engine. I think they also support vector storage and searching for data by comparing vectors using similarity functions, which is similar to what MongoDB Atlas vector search allows you to do.
Sure. Okay, cool.
So yeah, both things are supported as well in Elasticsearch. Yep. All right, let's see what else is there. So why do we need these vectors, and how do we get them eventually? Each of the numbers here are actually parameters, and they score a different characteristic of the thing that we vectorized. And again, they're from -1 to 1. So you can imagine how different features of an object can be scored using this scale. And in the end of the day, the whole idea of using vectors in machine learning is to embed some data. So we get a piece of natural language, like a text or another media. We run that through a vector generating model, and we get a numeric representation. And again, you can imagine why this is very powerful. We can have different types of text, different types of media, different lengths of text. And in the end, we boil that down to just an array of numbers that we can compare and we can kind of work with. The idea is that words that have close semantic meaning should have similar vectors. Now here we have these two texts, and they should produce kind of similar vectors. In the term that if we were to plot these multidimensional vectors on a multidimensional space, they will be closer to each other than other two vectors that are semantically close. So man and woman should be semantically closer. That's why they're vector closer than the vectors of apple and orange. And by plotting all these vectors, we should be able to identify terms that are close to each other. If it doesn't make sense yet, it will soon. And generally, we're using an algorithm that is quite well-known algorithm. The most simple one that is supported is k nearest neighbors. K is the number of near neighbors that we want to find. So when we search for ancient civilizations, we want to find the, let's say, the 5 closest vectors to our vector that comes from ancient civilizations. And that's how we find the books that are close to our original query. And that's it. It's not magic at all. It is actually pretty simple, and it boils down to these 3 steps: generating the vectors, or also embeddings. Again, embedding is the vector representation of some media, of some text or an image or an audio. Then building a search index that will allow us to compare these vectors and get the similarity score out of them. And finally, sending search queries to find similar items. Yep.
So we're going to get an opportunity to run through some of these 3 steps then now, Mira.
Yeah. I'm not going to do any live coding today, probably thankfully for everyone here. But we're still going to see some code. And we also have this demo that I showed in the beginning in a GitHub repo that is publicly available and has very elaborate steps on how to run it. So if you want to try it at home, please feel free to, or if you just want to steal some of the embedding generation code or the sending a search query code, just go ahead and do it. It's free and open licensed, if that's a correct word. Yeah, this is the repo that we have on screen.
I put up the repo. If you're in GitHub, you can just search for that. I will have a short link I'll throw up in the comments as well too shortly that'll get you directly there as well too. But as with an awful lot of the work the developer relations team does here in MongoDB, everything ends up in that open public repo, MongoDB/developer. You can see most of the content that we create, most of the tutorials, etc., is all there for you to take and learn from yourselves. Use it as you wish. If you can enhance it and make it better, by all means PR it, and we'd love to take a look as well too. We do love to get community contributions, so do help out there. But if you want to, maybe not now, but concentrate on what Mira is running through, but after this, go to that repo and play with it, not for it, play with it yourself.
Yeah, definitely. And just to show that I do have a README with instructions. It's here. The only prerequisite is to have Node.js installed. It's not like a requirement to work with vector search or MongoDB Atlas, but the scripts for generating embeddings and running the application just use JavaScript. So you can go ahead, clone the project, prepare the data. There is all the data set, book data set here in this repo, so you have it available. You can create a free account in MongoDB Atlas, and you don't need like a credit card or anything. If you don't have an account, you can create it literally in a couple of minutes. Load your data there, and let's see what else is in there. So then you can generate the embeddings that I keep mentioning here using Google Cloud. Again, for Google Cloud, you can start a free trial if you haven't already, if you don't have like a billing account there activated. And you can run this function that I have prepared for deployed and run it to generate the embeddings for all of the data. And then finally, there is like a little client application that I showed you. There is also instructions how to build a vector search index, which is also free with the Atlas free tier. It's pretty simple and very, very descriptive. If you find any issues with the README, please open an issue.
Okay, and I have a shorter link there now for anybody who not as short, or well, not shorter. So all of the short links that we use here, you can get easy access to mdb.link, and then just / Google Cloud Semantic Search with hyphens in between each of those words. That will get you to the repo that Mira is talking about.
Yep. Indeed. Okay, let's go through the steps, and I'll show you bits and pieces of the code that you can just go and steal from GitHub later if you want to use them. I saw a question here. We're going to get to that later. There is someone asking if you can use a different algorithm instead of k-nearest neighbors. We're going to get to that when we go to building a search index. The short answer is right now, no. The algorithm that is used by Atlas Search under the hood is always the same, and you can't modify it, but you can modify the similarity function, which should be enough for now. But if you want more extensibility in terms of algorithms, maybe just wait for a while. We might have something coming up, or use a different solution.
Excellent, thank you.
All right, so how do we generate the embeddings? First things first. The short answer is you have some data, you send it to an encoder, which in our case will be Google Cloud's text embedding-gecko model, which is available within Vertex AI. And this encoder is usually just a black box. You don't know how it works. It is trained on a large amount of data. That's why it's context aware. That's why when I send the query Harry Potter, it knows that I might be looking for wizard, fantasy, or magician books, and it shows me these types of books. And again, this encoder uses all of its knowledge. It is trained on a vast majority of data, and it outputs a vector. So it's the actual definition of a black box. You send in some data, and it outputs a different format of data, which is the numerical vector. It is not fine-tunable, which is unfortunate, but I don't think right now there is like a popular commercial encoding model that is fine-tunable. They're all just trained on the LLM that this platform uses. And as I mentioned, you can send multiple types of data, not just documents or text. You can also send video, audio, images, all that, and get an output vector. Again, the sizes of the vectors might differ, so you can't actually easily compare text vectors to video vectors. That won't really work. But you can use them to enrich your information or your search experience. So we have a generation script. I'm going to show that in a second. What we do is we get the data from our MongoDB Atlas database. In this example, we are working with books. So we're going to fetch the book documents from the books collection. We will extract all the meaningful data from it. For example, the synopsis of the book or the title or the author. We will concatenate all that into one chunk of text. We can send that through a Google function to the Vertex AI Palm API, which contains the text embedding model. We will receive that vector back. The function will return it back. The function is just for kind of usability purposes, because the Google Cloud function is serverless and is generally very cheap. It has a very generous free tier. That's why we're using a cloud function here and not like a self-hosted server. But you can use whatever you want. Finally, we're going to get that vector back and we're going to store it back into our Atlas database, into our books collection alongside the rest of the books data. Now, this is really important. We're not using a separate vector optimized database. We don't have a separate storage solution. We are using the same operational database that we use for the rest of our application. We just store an additional field containing the vector inside it. Now, let's see that we have this book here. We saw it earlier, the C.S. Lewis book from the 1950s about magicians that shows up when we search for Harry Potter. So what we're going to do is we're going to select all the meaningful information. We're going to select the title, the author, the synopsis, and we are going to send that over to the model as one piece of text. The idea is that the more data we have, the better the resulting vector. Sending a call to the model is really, really simple. Here I'm using the Python library, but this is nested within a Google Cloud function, so it doesn't really matter which language you're using, but we are importing language models. This is all of our text that we grabbed from our database, and we are building the model or instantiating this object here from the pre-trained text embedding-gecko model. And finally, we're just calling model get embeddings, and we are passing the text. That's everything you need to generate a vector.
We got a related question, Mira, from Ahmed. Can I generate embeddings locally? You maybe could if you had a lot of time and a lot of effort for a long time. This is why we use essentially embeddings from third parties. They have been training these models for an awful long time. And I think that, of course you could, but, you know, I think standing on the shoulders of giants, these are large companies with an awful lot of time, effort, and years of data science and engineering built into these. So I think the key thing is why would you? What would be the advantage of that? The one thing that does happen with all of these, you know, embeddings, large language models, etc., is that, you know, they are trained on a finite set of data. And I think that if you have data that, you know, you're working in a company and you want to use tools like this within your own company, then you augment the model and with an adjacent set of content called essentially retrieval augmented generation. So you can pass the requests via your subset of data and back through some of these language models to help you, particularly in the chat environments, etc., as well too. I'd be correct in saying that, right, Mira?
Yeah. And I think you did have an episode about that just a couple of days ago or last week.
We did with a tech partner of ours, a company called DataWorks, and that's what they do. So they actually are very agnostic. They work with all of the key providers in the LLM space, and they allow you to do exactly that. So you can incorporate, you know, the large language models allow you to query in such an easy way that incorporating your own enterprise data that, you know, the large language models do not have access to, nor do you want them to have access to, nor would you want them out in the public domain perhaps as well. So that's how you would manage that inside an enterprise.
Yeah, definitely. I've heard about that use case from, again, companies that don't want to have their data outside of their own premises, like large banks or other large service providers that are not necessarily
Hmm.
very open to using a public cloud. And they do have the time, the resources, especially like the monitor resources to train their own machine learning models that are good enough to produce embeddings that are comparatively um, as quality good enough as the embeddings produced from Google Cloud or other providers. And I guess that is what Netflix does.
Hmm.
They do use vector search and they have their own machine learning models. But again, that's like a business that generates a ton of money from people being able to find what they're looking for and find the right things. Um,
Okay.
and
Juan
you can
posts
take
a
advantage.
question about instructor embeddings, Mira. I'm not too familiar with that myself. Can they run a semantic search against a collection if they're already using instructor embeddings?
I'm not sure what that is.
Yeah, I don't know. So maybe Juan, if you could jump in and add another comment, maybe to explain that, then it's something that we can answer.
I mean, if the vector is shorter than 2048 numbers in length, yeah, you can store it in MongoDB Atlas and you can build an index on top of it.
Hmm. Hmm.
So I'm not sure what instructor embeddings are, but if they match that criteria, then you can do it. Um,
Excellent.
yeah, cool, cool, cool. So again, if you're following the instructions in the README in the demo repository, this snippet will be part of a Google Cloud function that you can deploy on your own in your own project, and then you can call it from the publicly available URL to generate your own embeddings for your own text. There are certain quotas and limitations on how many you can generate, especially per minute. You can extend them, but they're mainly there for your own protection because after a certain point, you have to pay for these calls, and you don't want to overdo it.
Yeah, there's a well, you know what I mean? Obviously, there's a round trip going on there. You know, these are being built by companies. Yes, they're
Mm.
mostly available to experiment with, but yeah, if you're putting too much load and too much bandwidth and too much compute back on their system, yeah, there's going to be a cap and a fee will come into it after that.
Yeah, yeah. But again, it's not that much. I think I generated like 500,000 of these, and I had like
Mhm.
$10 at the end of the month. So it's not too bad. So Juan
So,
replied, it's another embedding model available through Hugging Face. I haven't tried it myself, but I think it should be possible because we are partnering with Google with Hugging Face. Sorry,
mhm.
and I've seen people use their APIs with vector search. So I would say go and search for that in our documentation, but I'm pretty confident it's possible. That's good though. It's a good question.
Thank you, Juan. Yes, yeah. So, next steps then. So, after this,
Next step. So we generate the vector and then we put it back into our document. As I said, and as you mentioned as well, the vectors in MongoDB, they live right along the rest of the data in your documents. And this makes it really easy to manage these vectors. You can regenerate them if you want. If some part of the data changes, you can extract them to use them in another system. You can again build a vector index and search for these documents, which is probably the biggest use case that people use these vectors in MongoDB for. So we put the text embedding here, the vector in here, and then we can use Atlas Vector Search to build a search index on top of it and search for documents using vector search. The Again, the biggest benefit of MongoDB Atlas is that everything is in the same place. So you have your database hosted in one of the major cloud providers. You have um, Atlas Search, which is now full text search together with vector search. You can use one or of the two, or the two of them in your application. And you're querying all of your data using the unified MongoDB query API. You perform your searches again using the same familiar language that you know, which is the MongoDB query API. You can start using it and querying for that data right from the driver that you're using, that you're connecting through to your MongoDB database. It's all unified, and that's kind of the whole point of having a data platform. Everything's in the same place, and it has like a unified experience. All right. So I'm going to skip through these use cases. We saw semantic search. There are many other use cases for vector search, but again, you can check them out. The point is to see how to actually make vector search work. So how do we build this search index? You can go to MongoDB Atlas. Actually, let's go to Atlas. Not sure if we have the time. Yeah, we do have some time.
We do. We're good. We're good.
All right, let's go to Atlas over here. cloud.mongodb.com again. Free to sign up, free to deploy a cluster, free to build a search index. It's pretty easy to use as well. This is my free cluster, and if I go to the collections, you will see the books that I've been talking about. This is the demo that we saw running. It is running on that data. So we have a bunch of information in our documents, and we have this text embeddings field, which is the vector that we generated through Google Cloud and we stored in our database. Now, how do we use it? We go to search indexes. With the free tier, you get 3 free indexes. I have used all of them. So I'm just going to show you the actual index on this bookstore books collection. I'm going to edit it. Let's say JSON editor. And this is the definition that you also saw on the slide. So what does it mean here? So we are going to create mappings, and we're going to be mapping the field text embedding, which stores our vector, to an index that is of type KNN vector. Now, as you can see, this is the only option here. I'm not sure if you can see it, but maybe if I try to change it, you'll see that it's invalid. So I can't put anything else in here. KNN is the only algorithm that vector search supports right now. So we're building a KNN vector search index. It is using a similarity function called Euclidean. We have 2 more options. We'll go through them. And we need to specify the dimensions or the length of the vector. Now, what this means is that I cannot put heterogeneous vectors into the same collection, into the same index. So I can't generate a bunch of indexes for text with Google Cloud and then a bunch of indexes for text from OpenAI and put them into the same index, because they have different dimensions and they generally have different meaning as well, because they are produced through different models trained on different data. That's why this is important, and that's why it's fixed. And you need to kind of understand that, because I didn't understand it. And I was trying to compare different types of indexes. If I hover here, you see that we actually have this really cool tooltip come up. We have 3 types of similarity vectors. We have Euclidean, which measures the distance between the ends of the vectors. We have cosine, which measures the kind of the angle between the vectors. If you imagine them as 2-dimensional vectors plotted on a 2-dimensional plot, this is like the angle between them. And we also have dot product. There are different best practices which similarity function you should use depending on the type of data that you have. In general, for text data, I've read that cosine is better. I'm going to keep it to Euclidean because I didn't really saw a big difference in our small data set. But again, depending on the type of your data that you have produced, just play with them, see which one produces better results. and see which one is best for you. But that's the whole building the index part. It's like, this is the whole definition. You can go ahead and save it. It takes, again, I guess, a couple of minutes for the free tier to build this index. Again, depending on how much data you have. And I have already built it, so no need to rebuild it here. But when we build the index, and these are the similarity functions that I mentioned, again, check which ones are better for the type of data that you have. So when we build a search index, we are ready to send a search query. Now, I mentioned already that you're using the regular MongoDB query API. That's why you can just go ahead and say collection.aggregate and use the $search operator. If you're familiar with MongoDB, the aggregation framework is something that you have used. And the search operator is probably also something that you have used if you've used Atlas Search before. And here you need to specify that you're using KNN comparison. You need to pass in a vector here. Now, this is the interesting part. As you saw, we have converted the data into our database to vectors, and we stored it, and we built an index on it. So when we want to search through that index, through that vectorized data, we also need a vector. That's why we, when we type into our search field a query, we need to go and create an embedding for that query. And we need to create an embedding or a vector using the same model that we used for generating the rest of our vectors. So in this case, I'm just going to use absolutely the same Google Cloud function that I used for generating the embeddings for our books, synopsis, author, and title information. So we generate that vector. It doesn't take too long because it's just like a single text. Usually we put that into the aggregation pipeline, and we also specify the key, the key for key, and then again play with this vector or this parameter to see which one works best for you. I guess the default is 20, so that's fine. Let's see how that looks if we connect it to our application. So what happens actually? So we have our application, we type in a query, the query goes through that Google Cloud function, and we generate an embedding or a vector using that query. So when I type in Asian civilization, I convert that to a vector. I send that back to the application, and the application uses a MongoDB driver to connect to Atlas Search using, again, the aggregation framework that we saw, the aggregation pipeline that we saw. We send that vector and we perform vector search. Atlas Search knows how to do that behind the scenes for us. And it is not that big of a black box because it uses a well-known algorithm. So you kind of know what the results might be. If you're curious how it works, just put in some very tiny vectors with maybe 2 or 3 numbers into your documents, generate a vector, and start sending queries and see or observe the results that come back. And you will be quite capable of debugging what is happening or like understanding how the calculation works.
That's a nice tip, actually. I hadn't really thought of that way. You know what I mean? To get your head around this, yes, do it in that method. I hadn't even thought of that one. That's a good one.
It's really cool. Eric from our team, Eric Hatcher, who is probably well known to anyone in the search community, showed us that trick yesterday. I'm in a project that is probably not very shareable yet, but it's a really cool trick, definitely.
Excellent. Shout out to Eric there. So yeah, definitely. Yeah, that's a nice one. I missed that conversation yesterday.
yeah, it's a cool demo. But anyway, so when you get back the results from the search index, you'll basically get them in an inverted format. So you'll get the similarity score and the ID pointing to the original document. And from this ID, you can then go and find the actual document in the books collection, because that's kind of how
Hmm. Mm,
the Atlas search indexes work. They're kind of inverted indexes.
makes
Um,
sense. Yeah.
so you have to look up the original collection afterwards to find the results. And you get back the results in your application. This is what we saw earlier. Let me show it again in case someone joined later. So we have this search over here. There was another interesting search, European history. See if it works. The
See, it's
slow
a
part
live
here,
demo.
as you
There you
can
go.
see, the slow part is actually the first query, because we're using the Google Cloud function and it needs to boot
You
up.
start it up
There's
again.
like this,
Okay.
yeah, so there's this cold start problem with it. But if I search for another thing, it will
Hold
be
on, hold on.
immediate.
Don't move from there. I was loving
That's
the first search result. How the Irish saved civilization.
that's why I wanted to show it to you.
Oh, you knew that was going to come up.
Yeah,
I love it.
it's
If anyone
yeah.
can't tell from my accent, I'm Irish.
Yeah, we
I do.
already discussed that. Don't want to embarrass you, but yeah, that you kind of switch to a more American accent when you're doing this live stream. So
It
if anyone
depends. Yeah,
didn't guess,
yeah.
Shane is Irish, and yeah, he's not hiding it.
Yeah, we see if I
But yeah,
put on my proper Irish accent now, that maybe our global audience wouldn't necessarily understand me so easily. So I do tend to change it a bit, as my family keep giving out to me if they ever catch any of these snippets of live streams.
if they can handle my accent, they'll be fine with yours.
Well, listen, you got to love that book, though, How the Irish Saved Civilization. That's certainly one for my Christmas list.
Definitely, I never heard about it before, but yeah, now I want to check it out.
And you had another search you wanted to show, a different
I don't
take
know.
on that
This one
thing?
is fine. This one is fine. So
Okay.
something else that is interesting here is that we see this book that it is not in English. It says French edition, and we have some um, snippets of, I guess, text in French here as well. And I had other like samples of that in the rest of the data set.
Hmm.
Um, and it's important to mention that Google Cloud's embedding model is multilingual, if that the right English
Yeah.
word for it. So it
Yeah.
can understand different languages, and again, it has been trained on multilingual data. So if we search for a different language or European history, it will probably find books that are related to European history, even if their synopsis is not in English
Okay.
necessarily. So that
Excellent.
is something that kind of differentiates Google Cloud's embedding model from other more popular
Hmm.
embedding models.
And that probably serves the previous question too. Can you create your own embeddings? Yeah, of course you could, but you're getting multilingual in this instance as well too, right?
Yeah, yeah, there are a lot of powerful
Hmm.
capabilities, and as you can guess, like this um, services, let's call them, that are just getting started, and it's obvious that like OpenAI and Google especially have a long history of machine learning um,
Mm.
research and also products, and it's exciting to see what will come up afterwards, because what we see as the general public, what we see available is just like a very tiny portion of what Google has and uses um,
Yeah, and anybody
for
that you
their own
talk to,
products.
yeah, I mean, this is, viewed as the next phase of the internet. And machine learning and AI has been around for an awful long time. It's just recently, that it's come really to the public attention in the way that it has, since the middle to late, of last year, it really exploded. But this work is behind the scenes and I know from talking to some of them, huge teams, massive data science teams pulling this together, working on it for an awful long time. So it is it's a superb, a superb achievement in the short space of time, what it seems, but it's not. It's based on years and years of work. And who knows? I mean, the next, what happens in the next, 3, 4, 5 years time, the ChatGPT 3.5, 4.0, what's ChatGPT 10? Who knows? We got another question
Indeed.
in there, just Mira, if you have a bit of time, which was, and we did answer this, and maybe Binoy, if I'm saying that correctly, you joined us a little later, about specifying the indexed use of the search. So Mira had a piece of code up there that's saying essentially we are going to use this as the index for what we're going off to do.
Yeah, let me share that. Yeah, you can specify the index. It's just like another field in your query, um, with like a top level field within search. I can probably show it if I can find it over here.
Just while you're having a look for that, Ahmad, yeah, true. Some companies obviously don't allow to go outside their servers. That's really important. And, that's why you would look at your augmented generated models. Perhaps you can have those LLMs sitting inside. Some countries don't allow AI, right? Again, there's a lot of legislation, particularly in Europe, also China and other areas as well, too. And also in the context of GDPR. So, it is key. I mean, we're talking about it, that it can do so much, and yes, it can, but there is also those security concerns as well too about what's happening. And indeed, I know some companies, and we're talking about the big 3 cloud providers and all the AI work that they're doing, but some companies don't work well with those, and they only work with specific ones. So again, that will dictate what embeddings that you can use, what Gen AI tools that you can use.
Yes, definitely. And when I see that like kind of argument, I always remember our previous boss, Joe Drumgo. He had this saying like that companies they're very concerned sometimes to host their data on the public cloud, but they're not really aware that their own servers are a lot less secure than the public cloud, and it's kind of like
Totally. I mean, this is the thing, our MongoDB's developer data platform as it is, we do this day in, day out. And yes, you can get what we call the community edition of MongoDB and have it stand it up on your own servers and keep it on premise. But we have so many tools built on top of that in terms of performance and security, et cetera, as well, too, that, of course, if you have database administrators and people there to run and manage that on your behalf internally on premise, no problem. But why would you let your developers loose on creating amazing applications and leave all of the infrastructure up to us?
Yeah. But yeah, of course, it's like a sentiment that we hear all the time as people working with other tech companies. It does come up often. I just always remember that. Yeah, the cloud is a lot more secure than people expect.
Most definitely. So I know we're at the top of the hour. What other kind of suggestions for those? I know we covered it. Great demos. Great to see how you went through it. Hopefully, I think we could do, and we are doing future topics on this. I know our colleague Jesse has some live streams coming out in this space. I know that we're doing a similar live stream with AWS next week as well too. Same time, same place, same channel. And I think, as you alluded to, Mira, we're only getting started in this space. And I think the key thing is to, show how to use things in a realistic manner, in some way that explains things simply for developers. And your bookstore example, I think, exactly did that.
Yeah, and you can pretty much set it up for free. Like, it's a cool, powerful technique of search based on a real research in machine learning. And right now you have it available because of all these kind of, let's say, marketing advancements in the past year. It has been around, but it hasn't been so easily available. You can store your vectors, you can index them, you can generate them all for free, and you can just play with them. And you can see that they're quite popular topics today. And I believe as developers, it's good to kind of at least be aware of what is out there, how it works, at least theoretically. And even if it is for the purpose of like understanding who really knows what they're talking about when they say
Mm.
generative AI and vector search and AI ML, it will be easier to spot if the services that you're being offered are actually AI powered, or is if it's just like a buzzword that people are putting out there. So yeah.
Yeah, I mean, there is a bit of that, all right, too. I think at the MongoDB.local London event on Tuesday, we had a guest from Red Monk, James Governor, and his point was, and also we had Igor Alexiev from AWS join us, and both of them had the point that, this is, yes, the research and science behind it has been there for a long time, but the tools that are available, the platforms that are available to us now are all really new. And it's just about, don't be worried, don't be scared, jump on board, play around with it. There's so many tutorials out there. We're really only at the start of it. So, if you want to get into AI, if you want to get into Gen AI, large language models, embeddings, etc., jump on and get started. I think it's the easiest way to do it. You will learn a lot very, very quickly, and everybody is learning and only too happy to share as well. So Mira's repo is there. You can jump on, and as Mira said at the beginning, get started there, play around with that as well too.
Awesome.
Perfect.
Thanks for having me today. And
not at all. It's always a pleasure. I think I'm just trying to look through. Was there any other questions? No, I think we got through most of them in the flow of the show, which is always great. One that just came in there was the vectors added as an array field cause performance an issue because they're unbounded.
Yeah, the short answer is that they're not unbounded in the sense that you can build a search index only up to 2048 as a size of the vector you can have. So yeah, you can have. I mean, you can have like a longer vector, but it will be useless. It won't work with Atlas search. So you can pretty safely put them in there if they're within that size. Otherwise, they will be unusable from Atlas.
Okay, so look, Mira, this has been superb, enlightening. This will not be the last Gen AI talk you're going to do, I think. And as a DevRel team here at MongoDB, I know that our remit over the next number of months has a huge amount of AI content. If you're ever looking to learn more about our products or anything else that the DevRel team and the other engineers and product managers put out here in MongoDB, we have awesome developer tutorials. Go to developer.mongodb.com to our developer center, where you'll see content by Mira and tons of our other colleagues there. And regardless of what language you choose or what platform or cloud, etc., as well too, you just pick. You can filter by your language of choice. If you go in there, choose Python, choose JavaScript, whatever way. If you want to go and see the tutorials that we have with Google Cloud, for example, you can choose Google Cloud there, and it will filter all of the content that we have. Likewise, AWS and Azure as well too. So that's really, really a vital kind of, I suppose, resource for most of our developer community. Of course, our forums are superb as well too. So if you are experimenting and playing around with anything that we're doing here at MongoDB and looking at our content, our DevRel team, our community engineers, our triage engineers are always on our forums, and very straightforward to jump in there. You can browse through our topics and you can see, hopefully somebody has already asked the question that you're about to ask. And if not, do ask the questions. Our community is incredibly vibrant. We love to see that other community members answer. It's not a support forum necessarily, but they're helping each other all of the time. And yes, our engineers there and our product team are there too. But do you know what? Usually it's a community, somebody from our community that answers somebody else as well too. Another plug, selfishly, the MongoDB podcast. Myself and my colleague Michael Lynn share the MongoDB podcast, so do check that out on whatever podcast platform you have and subscribe. And if at all possible, do leave us a review as well. And this is the Cloud Connect show. We do this every Thursday, most Thursdays. Sometimes there's a break, but most Thursdays, 5 p.m. GMT, 12 Eastern, 9 a.m. Pacific, and all of the other time zones in between. But as I said, they are all recorded and available up on MongoDB YouTube channel. If you go into the live tab, you'll see them there, or just use that short link, MongoDB.tv will take you. And we are announcing some new shows coming forward, and I know in January we've got broadening that out as well too. So we very much look forward. We've got tons of developer content coming down the tracks there as well too. Yeah, so that's the end of my plugs. Any last few words for our audience who've joined us here today, Mira?
Oh, thank you for joining, especially the folks from Asia, for
It's
whom
late,
it's very
yeah.
late now. Yeah, but thanks for staying on. We also have like MongoDB user groups. If you're into live events and live meetups, check them out. You can just Google MongoDB user groups. You'll find them at one of the links there. But yeah, it's always nice to do this, and thank you for staying to the end, for everyone who stayed here.
Yeah, we do appreciate it, and share the word if you enjoyed this. Thank you for all the nice comments we see coming in as well too. And we look forward to having you join us on another episode. Mira, thank you so much for once again making something so clear and easy to follow and easy to understand, and demystifying what is new for a lot. So we do appreciate that, and your insights are great. And as you know, you're always building some great tutorials, so I can't wait to see what you build next.
Thank you for hosting me here.
No worries. Well, listen, thank you for everybody for joining. Until next time, next week, take care and look after yourselves. And thanks again. We do appreciate your participation with all the comments. And it's great to see the breadth around the globe to which everybody has joined, as Mira says. So take care, everybody. It's been a great episode. Thank you so much.